In this video, I'm going to show you how to solve a system of equations using the calculator. All right. First, at the bottom of the screen, I have shown the different keys that we're going to be using when we're doing this. We'll be using the y equals key, the zoom 6, zoom 8 enter, trace, the left and right arrows, the up and down arrows, the calc feature, and intersect. Alright, the first thing we need to do is go up there and get ready to use the y equals key. And in order to use the y equals key, we have to have y alone in both equations. So the first thing I'm going to do is take the equations and write them down separately. So I have 1/3 x plus 1/2 y equals -1/3. And the other equation, 1/2 x plus 1/3 y equals -4/3. And the first equation I'm going to multiply by the common denominator 6. And I'll get 2x plus 3y equals -2. And since 6 is the common denominator in the second one, I'm going to multiply by it there too. And I'll get 3x plus 2y equals -8. And then I'm going to try and isolate x. I'm going to work with the first equation until I finish it. I'm going to subtract 2x from both sides, and I will get 3y equals -2x minus 2. And then I'm going to divide by 3 on both sides, and that affects every term. And I'll get the equation y equals -2/3 x minus 2/3. I'll be doing the same thing with the other equation. First I'll subtract 3x from both sides, and then I'll get 2y equals -3x minus 8. And I'll divide by 2 everywhere. And my y equals there will be y equals -3/2 minus 4. Okay, and I'm ready to go. All right, and so let's turn on the calculator. And go to the y equal key and clear out anything that's in there, and go to y1 and enter the first equation in the y equal form, which is y equals -2/3 x, which is the x key next to the alpha key, minus 2/3. And go down to y2 and enter y equals -3/2, 3 divided by 2, x minus 4. Alright, and we're going to hit zoom 6 next to get a graph that is in a 10 in each direction. Zoom 6 is the standard graph that goes from -10 to +10 on both axes. And you can see it's intersecting somewhere in the second quadrant, approximately at somewhere between 3 and 4. Well, I'm not sure. At any rate, so so we've got it graphed. Now we want to graph it in a different window, and I can kind of show you why. If I want to look at XY coordinates so that this would be easy to graph on a test or a homework assignment. And if I hit trace, my XY coordinates just don't look that great. Look at X and Y here. They're horrendous. I'm going to hit zoom 6 again to start out because zoom 6 centers your graph for you in a 10 from -10 to 10, and then I'm going to hit zoom 8 enter to get it in an integer window. Let me hit zoom, and I'm going to show you when I go down to 8. This gives me the integer window, and I'll hit enter, and I might have to hit it twice until you see it regraph. Okay, and now I want a table of values. So I'm going to hit the trace key, and notice that the first function comes up, or the first line, y equals -2/3 x minus 2/3. And it gives me the y-intercept on it. And that's not a very good point to graph because it's 0.6666, -0.6666. At any rate, go to the right with the right arrows. We're going to be using the right and left arrows to change the x value and until we get a nice one. And so we got a nice value right there, which is 2, -2. So let's make a table of values for that. And 2, -2 will be our first value. And let's go to the left a little more, or to the right, I mean. And here's another point, 5, -4. So we're looking for ordered pairs that we could actually graph. And then let's get one more. 8, -6. That's a good one. And then we'll do the same thing for the other line. Now, the way we switch lines is we switch y by going up and down. Well, you can, since there's only two lines there, whether we go up or down doesn't matter. If I hit the down one, it'll go to y2. If I hit the up one, it'll switch. And notice up here now we're at y2. So hitting an up arrow or down more than once, it'll keep switching it from one line to the other. You can see the cursor moving between the two. Okay? And so I'm on y2 now, which is the -3/2 x minus 4, and I want to make a table of values for that one. And so that's a good value, except 16, -16 is not going to be able to be graphed on the graphs that you see on MMLP. So let's go find a value that's less than 10 on each axis. So that'll work, 2 and -7, so we'll put that in there. And then let's find another value going to the left here. 0 and -4. And let's get one more. -2 and -1. So you hit the left and right arrows to switch your x values and to get different ordered pairs. You hit the up and down arrows to switch which line you're on. Okay, so now we could plot both of these lines easily using the graphing tool. All right, now let's find the intersection. All right, notice calc is right above trace, right here. It's in yellow on my calculator, which means it's the second meaning of the trace button. So I hit trace, I hit second first, and then I hit the trace, and I'm in the calculate function now, and I have a menu here. And I'm going down to 5, or just hitting 5 for intersect, and it's going to let me find the intersection now. Okay, first curve, you could have 10 curves, so we'll say first curve y1, and that's just fine with me. Okay, and generally if you have lots of intersections, you make the cursor to be sort of close to it, but it's already sort of close. So I'll hit enter because that's the first curve I want. And y2 is the second one, which is really a line, not a curve, but that's all right. And then it gives a guess, and then it calculates the actual value. And the actual value of the intersection is negative 4, 2. Now you still have to check this, and checking always requires going back to the original equation. So let's do our check up on the top, and let's get out of this screen. And you can always play it again to look through how we did this. All right, so sometimes to get out of a screen you use quit. If I hit clear right now, it doesn't get me out of the screen. So quit is above mode. Second mode gets me out of there. And I want to just calculate this, and so I'm going to do, for my check, I'm going to put it back in the original equation, see what I get. 1/3 times negative 4 plus 1/2 times 2 equals, and it should equal a negative 0.3333, repeating threes, which is negative 1/3. Okay, and let's see if it does. Okay, and so 1 divided by 3. Well, I'll tell you what. Since you might not know that that's 1/3, let me just put negative 1/3 there. Alright, so I'm going to put a negative 1/3 right here. And we'll just make sure that both sides are equal. Alright, so on the calculator we do 1/3, open parentheses, negative 4, close parentheses, plus 1/2, 1 divided by 2, times 2, close parentheses, enter. We get negative 0.3333. We just write that right there. Negative 0.3 with a bar over it. And on the other side we have 1/3, which we just go it's negative 1/3. Negative 1 divided by 3, enter, which is also negative 0.333. We just write it there. So it checks in the first one, it makes both sides equal. And it should also solve the second one, so we're going to enter 1/2 times negative 4 plus 1/3 times 2, and it better equal a negative 4/3. Alright, so we'll go 1/2, 1 divided by 2, parentheses, negative 4, close parentheses, plus 1/3, open parentheses, 2, enter, and we get negative 1.33333, so I'll just put a negative 1.3 and a bar over the 3's. And on the other side, negative 4/3, negative 4 divided by 3, enter, is negative, the same number. So it checks in both of them because it makes the left side equal to the right. And that's it. Let's go over this briefly. The first thing that we did so that we could use the y equal key was to get y alone in both equations. And then we put it under y equal, y1 and y2. We hit zoom 6 to get a centered graph, then zoom 8 enter to get nice values on our graph. And then we hit the trace key with the left and right arrows to get a set of ordered pairs for y1, the first equation. And then we used the up or down arrow to get to the second equation and did the same thing with the trace key and got a set of ordered pairs for that, for graphing. Then we went to Calc feature and we selected intersect, and we agreed with y1 and y2 and the guess, and then it gave us the intersection point. And of course, we went back and checked it because we could have made a mistake, maybe the way we got our y's originally. We could have made a mistake in a lot of different places. So you always check your values, and you check it in both equations, because a wrong answer in systems of equation usually checks in one of the equations and not in the other. So you want to check it in both. And that was it.